exercise session number 6. So today we're going to have a look at, well, economic applications of what we've been seeing the last week, and that's also what we're going to start off, and then we're going to slowly move to, well, limits, what they mean and what they do, and then we're also going to have a study of, well, domain, range, and continuity of functions, as well as some asymptotes. So first things first, we're going to start with economic application as well as have a look at domain, range, and continuity. This is a bit of a recap where concepts of the previous class come together. So this is a bit, well, separate from the rest of the class, but it's good to follow along. So we're going to go to exercise number, the exercise series of economic applications, and we're just going to start with exercise number 4. Don't worry, this is not the only one I'm going to make. I'm also going to make part of 2. But I think this is where the most basic concept, well, starts. And there are other ones that are pretty much solved in the same way, but they are a little bit less challenging. So let's have a look. So here it tells us that the supply of a function of the supply function of a product is P is equal to the square root of Q plus 10. And it also tells us that the demand function, supply demand, is equal to 20 minus Q. And then we are asked to find the equilibrium. So to find this, well, we should assume one thing, and we should say, well, in the market equilibrium where demand and supply are equal to each other, it means that the price that the suppliers are willing to sell for is the same price at the customers, well, or the demand that they are paying for it. So we can use this and we can equal these things together. So we can say 20 minus Q is equal to square root of Q plus 10. Okay, this should immediately bring you back to a couple of classes ago, because, right, we're dealing with a square root on one hand, and on the other side, well, we have something that, well, is affected by it. Meaning that this square root will tell us that we're going to have a power condition, basically. We're also going to have condition for existence. Maybe we can look at that at the beginning. Basically, it means that the quantity sold needs to be greater or equal than negative 10. Of course, in a real-life setting, this is never going to be really relevant because you're never going to sell less than 0 products. Okay, but your power condition tells us that 20 minus Q needs to be greater or equal than 0. Or, in other words, Q is less or equal than 20. Okay, meaning that, well, this is going to affect our, well, domain of the function. This is going to affect our solutions of the function. So once that we have kept track of this, well, we can now square on both sides, and we get 400, which is 20 squared, minus 40Q plus Q squared is equal to Q plus 10 by just squaring on both sides. Okay, now, well, we bring everything over to the other side and we get 390 minus 41Q plus Q squared needs to be equal to 0. Now, where is that equal to 0? For this, let's calculate the discriminant. And the discriminant of this function is equal to 121. Meaning that Q has two possible solutions. It has 41 plus minus the square root of 121, which is 11, over 2. Which gives us the following two solutions. It gives us the solution where Q is equal to 26 and Q is equal to 15. Now we have to check whether these answers are okay. So let's first have a look at our conditions for existence. Q needs to be greater or equal than negative 10. Yeah, both of these are fine. But then you can already feel it. The power condition is not met for one of these two solutions. Basically, that says that Q is equal to 26. So that one is not a true solution. So for our answer, that means the quantity sold is going to be 15. We can now fill that in to obtain our price. So at equilibrium, I'll write a small e. We can also calculate what this means. Well, for your price, there you can choose either one of functions because they need to be equal there. The price function for the demand function is more easy to use in this case. So you get the price of demand, which needs to be equal to the price of supply, is going to be 20 minus 15, or in other words, is going to be equal to 5. So the equilibrium is going to be at where the quantity sold is 15 and the price is equal to 5, the price of the equilibrium. Okay, so that's if you have to calculate an equilibrium. Now let's go and have a look at exercise 2. And I'm not going to make A, but I'm going to show you how to make B. Because here an interesting thing happens. So first things first, we know a couple of things. We know that the demand curve is represented like this. So price for demand is equal to 50 minus Q. And the price of supplies, so the supply curve in this case is, it's quantity supplied is equal to minus 10 plus 2p. And here is going to be the price supplied. And now we see that the government is going to raise a tax on each of the circuit boards sold. So now we have to ask ourselves the question, okay, great, where is this tax going to have an influence on? So you could say, well, it could have an impact on the price of the consumers here in the demand curve, or it could have an impact on the price that the suppliers are receiving. And you will see, well, taxes, basically it means that the consumer will pay a certain price, but the supplier is not going to receive the entirety of that. A certain part goes to the government. So imagine like this. If you say, okay, the price of the consumer that the consumers pay, or the price of demand, is just going to be equal to price demand is just going to be equal to P. This is some different variable, and then here the price of that suppliers are going to be receiving is equal to P, but now minus 3. Okay, we can fill this in now. We get P is equal to 50 minus Q, and here we get quantity supplied, and of course these need to be equal, so we can immediately remove this S over here. It doesn't really matter that much, because, well, they need to be equal to each other in the equilibrium. And then over here you get minus 10 plus 2 times, and then you take your new measurement for your price, you get price minus 3. Okay, now let's equal these to each other, and you get that 50 minus P. So let's write 50 minus P is equal to minus 10 plus 2P minus 6. Okay, bringing this to the other side, you find 66 is equal to 3P, or in other words, P is equal to 22. So that means that at the new market equilibrium under this tax, so price equilibrium, I'll write a T there, because under the tax it means your price is 22. Okay, and then in other words, your quantity sold is going to be, you can now calculate it, it is going to be 28 at the equilibrium. Okay, so this P, let's be careful though, because I wrote here equilibrium, but it's this P over here. So that means that this is what the customers are going to pay. They're going to pay exactly this P, but the suppliers are of course going to receive something else. They're only going to receive 19 of this. So in this case, this is equal to 20T, and they are also only going to receive 19. If this doesn't make that much sense, I would like to refer you to your classes of macroeconomics, where you will see these more in detail, but this is just to have a general idea. Okay, now that we know that and we have had a look at that, we can now maybe make an exercise on continuity. So first I'm going to recommend a couple of exercises you do at home. So for these ones, I'm going to recommend for home exercise 1 and 2A. If you can solve these, well, you pretty much have the gist of everything else. Okay, Let's now move on to domain, range, and continuity, and we'll go to exercise 5. And the first one we're going to make together is question 5D. I'm not going to make that many on them because, well, we have looked at this in the past, but just as a quick refresher, I'm going to talk about it here again. So we get the third power square root of x plus 3 over x minus 4. Okay, now you have to ask yourself the question. Okay, we're interested in the domain. So the domain is what values of x am I not allowed to fill in here? So you might think, oh, I see a square root, so I'm not allowed to fill in negative numbers. But it's not just a square root, it's a third power square root. So it's an uneven powered square root, meaning that you can definitely have negative numbers as well. To give you an idea, the third power square root of negative 1 is going to be negative 1, right? Because negative 1 times negative 1 times negative 1 is just going to give you negative 1 again. Okay, so there's no restriction in that sense. Okay, what else could restrict us? Well, we have a fraction over here, meaning we cannot divide by 0. And this is going to be our own restriction. So we say, okay, our domain is equal to r, so the entirety of the real numbers, less 4. Because at 4, you are dividing by 0, and we can't do that. Okay, then now let's have a look at question E. And E is pretty similar as the previous one, but now we do have a square root instead of a third power square root. And in this case, well, we have to be a bit more careful. It means that, well, this is still going to hold true. We still cannot divide by 0, so we know that x needs to be different for 4. But we can also not allow negative numbers now. So how did we do this? Well, it meant that x plus 3 over x minus 4 needed to be greater or equal than 0. How did we do that? Well, we made a sign table, so we investigated the sign. So we said x plus 3 for the numerator and then x minus 4 for the denominator. And here we find at negative 3, our numerator is going to be equal to 0. Before that, it's going to be negative, and after that, it's going to be positive. Then here for our denominator, at 4, it's going to be 0, or we're going to get an asymptote over here. And then we find that here, indeed, it's also negative, and then afterwards, it's positive. We can bring all of that information together, and we find that before we hit negative 3, our function is positive. So I write here function, but this is of course not the full function yet because it's not a square root yet. 0, then it's negative in between there, you get an asymptote over here, and then it becomes positive again. Okay, so our domain is going to be restricted by this because, well, we can only take a square root of the function where a function is going to be positive. So only over here till it's negative and then starting here. Meaning that our domain for this function is x is an element of negative infinity all the way to negative 3 included, because, well, the function is just positive over there, so we can definitely take a square root of that, no problem. And then union, and here we get 4 to positive infinity. Positive infinity not included. Think for yourself, is 4 going to be included? So I hope that you had the same answer, but 4 cannot be included because, well, we're dealing here with an asymptote. It means it's this rule over here. Basically, 4 is not included in our domain because there we're dividing by 0. Okay, so that is an idea for your domains. Then let's have a look at question number 6. And here I'm just going to make one of them, and it's really to get basically a gist of the notation. So I'm going to make exercise B. And for exercise B, there is written, we have a function that operates within the real plane and maps onto the real plane again. Meaning that we take real numbers and we're gonna drop it somewhere in the real plane again. Okay, and then we know a little bit more about our function here. We just don't have any function. We have the function that takes values of x and then maps them onto square root of x. Or in other words, this is a long and very arduous way of saying we have the function square root of x. So really what this means is it takes numbers, for example, it takes pi and is going to map it somewhere within the real plane. We don't know where. and it's going to follow this rule. It's going to say pi is going to map to the square root of pi. So you see, this is how this function works. So this is some kind of notation, and it's useful that you know how to read it. Okay, so let's consider the domain. So the domain, we just have a square root over here, meaning that we cannot allow for negative numbers underneath that square root, meaning that x needs to be greater or equal to 0. Another way of writing it is saying we want all the real numbers, but only the positive ones. Then let's have a look at our range. So if we fill in all these numbers, where can we end up? Well, knowing that the square root can only spit out positive numbers, it means that your function is also going to be greater or equal than 0. Or in other words, your function is, the range of your function is r plus as well. If these don't make that much sense for you, really try to understand that there's always restrictions and that we're dealing always with the same things. We're going to have a look at a couple other ones later, but really these are the main things. Then I'm going to make one last one, but I'm not going to make it entirely with you, but I'm going to make 7c, because I think that's still a pretty tricky one. So you get y is equal to the square root of the natural logarithm of x squared minus 4. Okay, and now we have to think a bit. So here we have a square root, meaning that the logarithm ln x squared minus 4 needs to be greater or equal than 0, right? Because this is of our square root. Then we go a little bit deeper and we consider this over here, a logarithm of x squared minus 4. Well, that's going to give us somewhat of a problem as well, right? Because this can only spit out positive numbers, right? Logarithms don't like negative numbers. So you have a look and we say x squared minus 4 needs to be greater or equal than 0. Now we have to think, which of these two restrictions is the most strict? So here we can just read it off immediately. We can see that x squared minus 4 needs to be greater or equal than 0. So this is pretty clear, but what does it mean for this one? Let's work that out a little bit. And we say, well, this is very hard to calculate, but let's say e to the power of ln x squared minus 4. So let's take the exponent of both sides, and then here e to the power of 0. This will tell us that x squared minus 4 needs to be greater than 1. Meaning, if we look at both of these restrictions, this one over here and this one over here, this is clearly the strictest, right? So we're going to work with this one. Now use this one to calculate the domain of the function. So to find an expression that tells you what x should be. I'm going to leave you to do this at home. This is also pretty much everything that I had to tell about, well, these economic applications, and then some small exercises about domain, range, and continuity. In the next video, we're going to start with limits, and then in the last video, we're going to have a look at asymptotes. Okay, see you there.